Hello, everyone. Welcome to the Exercise 6 GC 100 tutorial podcast. I'm your instructor and host, Dr. VG. All right, so as described, this is a podcast tutorial for Exercise 6, focusing on understanding the relationships of radiation, so incoming solar radiation as well as atmospheric temperature. So what I've done is I've retrieved data, like real data of incoming radiation as well as atmospheric temperature from the National Weather Service station at K.I. Sawyer International Airport, which is Marquette's regional airport. And so before we do that, I want us to kind of take a moment. I want you to compile your thoughts after watching lecture contents related to incoming solar radiation and what that means in terms of like when radiation is at its peak during a day, and then how do you think that will influence our atmospheric temperature, so how warm it is during a given day. So now just kind of think about radiation over the day. It's morning, the sun comes up, our insolation starts going up and up and up until our sun reaches its highest point in the sky on that given day. And then the insolation value would then kind of go down and down and down until the end of the day. And after the sun goes over the horizon and it becomes dark, then there is no longer any more insulation coming. So what I'd like you to do, step one, is make a prediction, write a hypothesis. Do you think atmospheric temperatures, like the peak temperature, the warmest temperature of the day, do you think that's going to occur before, at the same time as the peak of incoming solar radiation, or slightly later than incoming solar radiation? So go ahead and make a prediction in terms of the comparative timing of peak insolation compared to peak atmospheric temperature. So once you've completed that, we can now go on to plot, analyze, and interpret our observational data. And so in step two here, we're going to use data from table one, and we're going to make a plot, a figure, as a graph, and it's actually a 2 y-axis graph, and that will become figure one. So let's start there. Once we have plotted these data, then you can interpret the data and go through and answer these questions. So I'm going to give you a digital demonstration of how to go ahead and plot these data. There's a few different ways you could do this. You could choose to print this out, and you could print this graph out, and you could then plot these data on this graph, which I'll show you in a moment. There's also a Microsoft Excel companion file you could download, and I will provide a brief tutorial demonstration of plotting data in Excel in just a little bit. But first, let's orient ourselves to table one and then subsequently figure one. Table one contains data in columns of time. So time, this is midnight at 0. This is 2 a.m., 4 a.m., 6 a.m., going to here noon, back down 2 p.m., 4 p.m., all the way to 10 p.m. And then what we have is actual recorded data of incoming solar radiation at K.I. Sawyer International Airport on August 17th, 2025, as it was. So I'm going to change that right now. And then here, you would expect, in the middle of the night, there's no incoming solar radiation. It's dark. So at midnight, 2 a.m., 4 a.m., and even 6 a.m., our insolation value is simply 0. But then the sun comes up over the horizon. It's at a very low angle, and we start receiving some incoming solar radiation, and then more and more. And then it starts going down again. And so then here we can identify our peak incoming solar radiation was in fact received right around noon on that day. So then our third column is air temperature in Fahrenheit. And so in the middle of the night, it was 61 degrees on August 17th, 2025. And then it was still 61. It went down a little bit to 60. But then right around the same time as the sun comes up, it starts getting a little warmer and a little warmer and warmer and warmer. And then it kind of cools off again, as you'd expect at night. So I want us to now plot these data. How do you go about doing that? Again, you could do this on paper. You would likely want to print this handout out and then simply and literally with a pencil or a pen record the data. So this is a two y-axis graph, this figure one, and on the x-axis is time and hours. So here's 0, which is midnight where we start here, and then it goes to 2 a.m., 4 a.m., 6 a.m. again to noon, and then back down to 10 p.m. or back to 10 p.m. And so here, insolation on our y-axis from 0 to 900. And so here's our insolation values here that we're going to plot. And so simply you would start at 0. And so here's 0 time, and that's in fact 0 insolation. So you would just make a point right here, and I'm encouraging you to use different symbols so you can differentiate the two lines that you will create. And so you could, if you, I'm just going to kind of show it here using Word, but you could do this again by hand. So I'm going to kind of just make a little symbol there, and you would put it, oops, put that out. You could put it right there on 0, 0. And so that would be your first point for insulation. And in fact, you would have 0 insulation, 0, 0 from 0 to 4 a.m. and 6 a.m. And so you would have a series of little black or little triangles here, and you put them on each of the, here's 2 a.m., you put another one, and then here's 4 a.m., put another one, and 6 a.m., finally, yet another one. So then as you kept going, here's 0, 2, 4, 6, and then you get to 8 a.m., and there is 20 watts per meter squared, which is not very high, but it is just above. And so you would put another triangle. And so Control, oops, Control Z, here's Control C, Control V. You would put another dot and you'd put it like slightly above the horizon to indicate, or best as possible, indicate where 20 is. And you would keep going. And so now it's going to quickly go up to about 400. So you'd have another point here and then higher and higher. And eventually this will kind of come back down, as you can see here. So go ahead and complete this line and work all the way through and make all the dots and then connect the dots with a line. Once you've completed your second column here, the insulation, now we're going to move on and you're going to plot temperature. So again, using paper and pencil or digitally or on the Excel file, which I'll show you in a little bit, you then actually still start at 0. So now we're going to use this column and we're going to use this column. And so you're going to compare just these two columns, and for here, you're going to ignore insulation. So at midnight, the temperature was 61 degrees. And so you would find 61 degrees here on this axis, but we're still going to start time in at midnight. And so here's 60 about, and so you'd make a point somewhere right around here. And so I'm going to say insert, I'll use a little circle symbol, and our point was about 60. So we'll kind of like add a dot right about here. So then we were right at 61 for the first multiple observations. You could go ahead and similarly kind of add another dot. I'm gonna, let's see, this might be kind of hard to do. That doesn't look right, but another dot, I'm going to move that down a little bit. And so then so on and so forth, dot, 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 and it goes down a little bit, dot, and you're going to keep going. And then eventually here at 10 a.m., it gets up to 76 degrees, which is right around here. And so then you would find 10 a.m. and 76, and you'd make a dot. And eventually you're going to have this plot that kind of goes up and over and down as well. What I've done is I actually plotted these data and I did it for the winter as an example. So the last page contains like a fully worked through example, but for the winter. And so I want you to go ahead and complete this exercise either on paper, and then at the very end, if you did it on paper and pencil or with a pen, you can simply take a picture of your completed figure and then upload it into question 2. I'm going to go ahead and just get rid of some of these dots. Oops. So that one. All right, so going back, we're still on number 2. Once you've finished your figure 1, simply take a picture and then upload that image into question number 2 when completed. So as an example, again, I've now plotted data for the winter, and actually this was for January 17th, 2026. And so these data were recorded in January. And as you can see, there's not that much insulation, a lot less. And then our temperatures were much colder, although they did slightly warm up in the middle of the day on January 17th. And so following the same sequence where you would start at midnight, go to 2 a.m., you plot your insulation, and then you plot your temperature. I just wanted to provide like kind of a fully worked through example here. So your final figure for this example, table 1 and figure 1 should look a lot like this one, although you're going to plot table 1 data, not here table 2 again, which is for January 17th, 2026. But just to kind of demonstrate here at midnight, there was zero insulation, 0, and there was just right at 8 a.m. we first observed a little bit of radiation at 2, and then by 10 a.m. it went to 14. And so to kind of follow along, we have 0, 0, 0, 0, and then 2, and then 14, and then your next point. And so you would make these several points, and then when you're all done, connect them with a line. So that's your incoming insulation plot. And then here your second y-axis from 10 degrees Fahrenheit to 18. You can then here, so at midnight it was 12 degrees, 12 degrees, and then in fact it's 12 degrees all the way until midday, until noon. And so you plot these data, and then it goes up from 12 to 14 or so, 15, and you keep going, and voila, you have your final completed figure. So now comes to the interpretation part of it all. So from 3 and 4, I'm really just kind of asking you, it's more like a result. Directly compare incoming solar radiation as well as air temperature, and then do the same thing. So what time was incoming solar radiation at its minimum? What time was at its maximum? What, and then so on and so forth. So for this example, for the winter, you could say, okay, the peak incoming radiation occurred at noon. However, the peak air temperature, as you see here, occurs later at 4 p.m. And so there's a 4-hour delay in the winter between peak incoming solar radiation and peak daily temperature on that day. So that's more question 4, and then question 3 to go backwards. It's talking about minimums, and if it says like a time range, for example, if there's no insulation between midnight and 6 a.m., you could simply say there was zero insulation between midnight and 6 a.m., and that would be a great response. Or similarly for temperature, the coldest temperatures were observed, and in fact, the coldest temperature here was reserved at 10 p.m. on January 17th. And so you could either do a singular point, the lowest or highest value, or if it occurs across the range, you can describe that range. So now moving on, there was 3 and 4, identifying the time and the when these peaks and valleys, if you will, highs and lows occurred. And so now providing a little bit of context for question 5 and then question 6. So it asks, what does the maximum air temperature observation lag? So if there was a lag between the temperature and air temperature peak happened later, like why did that happen? And so think about the lecture that's related with insulation, and think about the timing and what's in our atmosphere. Like what is in our atmosphere and what is on Earth's surface, and how do those materials interact with incoming solar radiation? Are there properties of the atmosphere that absorb incoming solar radiation? And if they absorb radiation, what then happens? Is it re-emitted? And if it's re-emitted, what is it re-emitted as? And is that a sensible heat? Do we feel that? Is there a reason why there's a lag between air temperature and insulation? And so the hint really is think atmosphere and think Earth's surface, and think about how they are absorbing, storing, and releasing energy, and use that to support your reasoning for why this lag occurs. And so now you can actually compare the data you plot here in figure 1 with the data that I've provided you in figure 2. And so going to the question, if we were to change from summer to winter, explain two ways in which incoming solar radiations would be different in December. And actually, you can kind of use it observationally. Look at your incoming solar radiation in the summer and look at your incoming solar radiation in the winter. What was different about them? Was one larger or smaller? Does one have a longer period where there's insolation received at Earth's surface or a shorter period? And so use that kind of comparison to answer number six. And finally, last but not least, I'd like you to use really your responses from questions 3 through 6 to synthesize these responses to evaluate your hypothesis. And so was your hypothesis confirmed or rejected? And so use these terms and the results from questions 3 through 6 to provide reasoning to support your response. Okay, one quick thing at the end, what you'll see is that we have this Microsoft Excel tutorial, and when you open it, you'll see this winter plot example, and you could actually click and everything's interactive here. And so here's 0, 2, 4, 6, 8. And so I just have these as numeric values matching this kind of time value. But then here, temperature from 10 to 18. So here's 12, 12, 12, 12, 12, and then 12, and then it goes to 14, which is right here, and then up to 15, and then finally to 16. And so the peak temperature, in fact, happened at 4 o'clock p.m. and it was 16 degrees Fahrenheit. Whereas for insolation here, we had 0, there's nothing, it's dark, it's dark, it's dark, it's dark. And then we start to get a little bit, and then our peak insolation happens right here in the middle of the day at noon. We have our peak incoming solar radiation received. And there was, in fact, in this case, in the winter, there was a 4-hour lag. So this is when we received the most radiation from the sun. However, it wasn't until 4 p.m. until the warmest part of the day was observed. So that's an example. And then I have this summer, which is blank for the moment. And you have the data right here. And so ways to achieve this, you could edit this winter example, you can go to the summer example, and you could add some points. And so one way to do it is to click on this graph and then right click and select data. And we're going to first start with our insolation, and we're going to click edit. And you could then just double check, but I should have it where your X is already correct. So you don't need to mess with or otherwise edit your x-axis. I'm just going to push enter right now, but we do need to update these y values. And so you could push y, and then you can click and highlight the range of y right here, and it'll show. And then I'm going to push enter and then enter. And right now I'm just going to push OK just to demonstrate that it did just make this one plot. And so again, I clicked right click, select data, and then for that, I clicked insulation and edit, and then I highlighted this new range from C3 here, C3, all the way down to C14, and it's showing the range of data. So I'll push OK, and then you could do the same thing for temperature, where you'll push enter. Here, the X is correct. We need to update the Y. I'm going to then click, drag, and highlight. And then as long as this is perfectly highlighted, I can push enter, and then OK, and voila, there was your plot very quickly, but I'm going to undo it here. But that is the demonstration of how you would do this figure digitally. And if you were to do that, then you can simply say Control C, and or you could save this as an image file, copy it, and otherwise paste this into Educat for question 2, and you could do this whole or you could do question 2 digitally, as I just did there. So I think I'm going to stop there. That provides a tutorial podcast for exercise number 6.